Hi, my name is David Lee. Today I'm going to talk about microservice for the cloud, how we can think about designing and implementing a microservice that is going to be running as efficiently as we can on the cloud. So before we start, we want to talk about what microservice is, right? It's really an architectural pattern. It's about composing distributed applications where each application acts as a distinct, separate deployable service that performs a very specific business function. So, as we're developing microservices, it is important to realize that the cloud platform may already hold very specific capabilities, and so we should think about how we should craft our microservice to best leverage those capabilities. As always, we'll start with a business case that will set the stage for our considerations and proceed from there. So the business case here is around this company called Contoso Pest Control, which is a fictitious company. The IT team at Contoso Pest Control has been tasked with the digital transformation of the business, and they're really trying to take advantage of the cloud and what it has to offer. The IT team plans to enhance the existing website that they have, as well as creating a new mobile app solution. The IT team also plans to leverage the microservice architecture when building out any new services. The ability to report issues by customer is identified as the highest priority item. So, they have a lot of customers who would like to go on a website or maybe go to a mobile app. And let's say that, they have some pest control issues, then this will allow them to create a ticket and that will allow their system to schedule technicians to come over based on their availability. So the IT team will leverage the issue microservice, which we'll call the issue microservice, to be used in their existing website. So what they're thinking is when their customers log into their account, they're able to create those issues, or once they have finished developing the mobile app solution, then they will be able to leverage this same microservice on the back end as well. So in this particular scenario, we have been hired by the IT team as consultants to help them with their digital transformation journey. And for additional context, they have selected Azure as their cloud vendor of choice, and .NET has been selected as the development language of choice. So, as consultants, we've been asked to provide some considerations for creating a microservice architecture that Contoso IT, wants us to, provide some of the considerations of what they should think about when microservices are developed, right? Fully taking advantage of the capabilities on the cloud. So the first thing is, the considerations that we're proposing is, we really need to understand the health of the microservice because it allows us to track if an instance is healthy or unhealthy. And if it's unhealthy, we really need to have a status endpoint, right? To be able to tell if it's, working or not, right? The other thing that we need to consider is service monitoring, right? We need to monitor the service whether as we're starting up the microservice or during the operational aspect of the microservice itself, we'll need some insights as to what is failing and maybe, review the logs to find out exactly what is happening. And perhaps, it will contain some stack traces, if there's any exceptions that are happening internally. We'll also need to consider securing our API. And the way that we're thinking about it is using an industry standard such as OAuth 2.0 token grant flow specification, right? Which is in an industry, it's used widely in an industry for securing endpoints today. So for example, one of the token grant flows is the client credentials flow, right? Where service to service communication is happening, or the authorization code grant flow, which grants access to a signed-in user. The microservice will communicate externally, obviously, in many ways. And one such way would be maybe to publish an event. So let's say, an issue is being created, that event will be interesting to perhaps a scheduler service and the backend. And if there's a pops up or published subscription kind of model happening, then the scheduler could, subscribe to such an event and be able to, perform some scheduling on the backend. Well, obviously, with events and other considerations, right, a microservice will start to have dependencies. We'll need to consider perhaps how we can abstract ourselves from the concrete implementation so we can focus on the higher level of the microservice business logic, right, rules itself. So then the next thing is API schema. And any API we expose will need to be discoverable version. And we also need to consider how to best test the API itself, right? If we have consumers, it will be best to have some kind of test harness built in, so consumers are aware, for example, hey, this requires a OAuth 2.0, client credentials flow code grants, and there are some ways that will help us with that aspect. For microservices, right, we do, or for some of the microservices, we do need to persist data to the database. And so we'll need to consider how to best manage the schema and migrate the schema to newer versions whenever we push new code to production. Right, and this is true for not just microservice architecture, but, again, something we will want to consider as part of proposing this, some of the solutions to the Contoso Pest Control IT team. The last thing that we want to make sure is to cover the how we think about pushing our code from development to production in a safe, reliable, repeatable way. And as much as we can, we want to be platform independent, which kind of speaks to containerization, right? Where we'll do a deep dive of this particular aspect in a moment. But this is really to help developers, have that low friction way of, having the code written, published, and pushed into production in a consistent, reliable way. Now that we've covered the various considerations we've been asked to propose to the IT team, we'll talk about some of the solutions. So the first up, we'll be proposing to use DAPR, or Distributed Application Runtime. It's an open source framework that allows developers to easily write their code without really having to worry about the underlying concrete implementation. So DAPR uses the sidecar pattern to realize this dependency abstraction because APIs are running alongside a separate process, which is DAPR. And it's trying to have that abstraction that you don't have to worry about certain considerations or concrete implementation. So as an example, Contoso Pest Control developers are very familiar with RabbitMQ, right? And they may say, hey, we would like to continue using RabbitMQ. But on the Azure side, there's also this cloud native service, the Azure Service Bus, for publishing and subscription of events. So rather than having the developers, perhaps pick up the Azure Service Bus SDK, learn about it, maintain it, right? What we'll do is we'll say, hey, you know what? There's this DAPR library that provides framework that allows you to be abstracted from it, right? So you can choose to, with little code change, right, go from RabbitMQ to Azure Service Bus because it's more effective that way. Perhaps you don't, you realize that now you don't have to maintain, services like RabbitMQ and focus on your business logic, right? So it gives us the opportunity for that kind of change later down the road. DAPR also has additional capabilities such as service discovery and service invocation, right? So, in a microservice architecture, there's bound to be more than one application or microservice running. And as more and more applications are being developed and pushed, right, you really need to have a good way to understand, the endpoints where each of the other applications are running. And so, DAPR has this service discovery capability where developers can just focus on their code, and do not have to worry about how to communicate with the hows of how to communicate with other microservices. There are going to be other capabilities with DAPR, but we'll not go into details for this particular presentation. The next solution that we're going to try to tackle is around data schema and access. And we're going to suggest using Entity Framework, which is a Object Relational Mapper, or ORM, that allows developers to map relational data using domain-specific objects, right? So from that perspective, it is very similar to DAPR, but there's some level of abstraction, right? But what we're really looking for is some level of abstractions from the concrete database engines. So developers can, for example, use the model-first approach, right, to map out their data entities. So today, right, Entity Framework supports SQL, SQLite, MySQL, MariaDB, Postgres, for example. But for our solution, we're going to suggest using Azure SQL, right? Azure SQL is a SQL PaaS offering where you are only responsible for maintaining the overall security, schema, and data. And Microsoft will take care of the infrastructure and software patchings and any updates. So this is going to mean less operational overhead for the IT team and their developers. And so since we have selected SQL for our database and for any future ongoing changes to the schema and migration of the schema, we're going to suggest using a DAPR, right, which is really a file format. It stands for Data Tier Application Package, and it's an extension to a database file. A DAPR is created with Microsoft SQL Server Data Tier Application, and it contains the database model for representing your database objects. Because it contains the complete model of the database, we don't really need to tell the how, right? We don't need to tell, hey, DAPR, this is, I have a new column or I have a new table, right? It just does it for us, right? So we don't have to worry about telling, the framework of the how. We just have to tell it what, right? This is what I want to happen, and it will do it for us. So that means no one needs to learn to write SQL scripts to do any of that work. All right, so we'll cover security next, and we're going to think about using the Microsoft Identity Framework, right? Because Microsoft Identity Framework really points to two different things: the Azure Active Directory, which already has the endpoints that has kind of the OAuth 2.0 endpoints built in, and there's two versions of AAD, right? There's the B2B and the B2C versions, and the difference is really who are the users, right? So B2B is used for enterprise users who are already provisioned by their organization, while B2C is for external facing consumers who have their own personal Gmail, Facebook, or other social logins. And so for our issue API, it is a microservice backend. And so we'll be using the B2B version of that, right? So we can think of, for example, using the client credentials flow, right, for that service-to-service communication. We'll take advantage of the Microsoft Authentication Library, or MSAL, which is just really, we can think of it as an SDK for developers. There's a .NET version that we can easily integrate. And for the demo, we'll actually be showing some of the code around MSAL as well. But that means we don't have to write our custom code for getting bearer tokens, right? It's all taken care of by the underlying library. Next up, we'll talk about OpenAPI and Swagger. So OpenAPI is a language agnostic specification that describes the REST API, right? So it allows computers, humans to understand the REST API itself without direct access to the source code. So really just like, XAML or XML or WSDL endpoints that describes data contracts, right? OpenAPI really achieves kind of very similar capabilities. And so what we're going to do is there's an open source, or there's a library called Swagger developed by a commercial vendor. And so if we're going to be using Swagger with some code configuration, it will generate the appropriate OpenAPI specification as well as a UI interface, right, where developers can browse to and start to look at the different APIs. So it makes API schema discovery easy, right, where anyone can just review the API. There's also the OpenAPI tool that allows us to leverage the OpenAPI specification. So it's available for consumers to directly consume and leverage. We should also mention that there is an API-specific service in Azure, which is called the Azure API Management, that can also be used, right? And we can use it as a front end, right? So if we think about it, right, having to consume the Open API with Open API specifications on our microservice itself, Azure API Management is able to consume that information and create an appropriate API representation, right? So from a development standpoint, that is great because we don't have to go through the Azure portal and design the API interface. It does it automatically for us because of the Open API specification. So, right, making advantage or making use of some of the capabilities on the cloud. We'll also be able to use Azure API Management for securing our front end with any of the OAuth 2.0 flows, which means our service wouldn't be directly impacted if there's ever a case of any attacks, right? The other thing is Azure API Management also is able to do throttling based on the number of requests coming to your API. So, for example, if you expect 10 or 100 requests per every 5 minutes, right? It can do that. So that your microservices isn't overwhelmed whenever there is a huge demand, or if someone is trying to attack, obviously that's going to go higher, and your microservice would be protected, right? Because API management is being is the front end to your API itself. The last thing I want to just say about Azure API Management is it allows you to gain insights into calls being made, right? So, rather than you having to build in those capabilities yourself, APIM does allow you to track the number of calls to each of the individual services or APIs. And so you can kind of gain some insights there and perhaps allow you to build out additional capabilities based on those insights. So and I did miss one point is, and this will be the last point of APIM itself, is it does come with a developer's portal and with a specific tier. And so instead of letting your developers gain access to your microservice itself, where you have a Swagger UI waiting, what can happen is APIM can provide a developer's portal. And so your developers could, in order to learn about your API, could just go to the APIM developers portal and learn about your API that way, right? This means, offloading the responsibility, and your microservice can focus on just being an API mainly and serving those requests. The next thing that we want to cover is around health checks middleware. So with .NET, the health check endpoint can be created with that built-in library through the health check middleware. And this library allows us to define, what is the URL endpoint for when someone is trying to check for the health of our microservice. and also define the business rules of what constitutes a healthy or unhealthy microservice. So as an example, we can consider the health based on whether there's an access issue to the database, or perhaps having to reach those dependent HTTP microservice. The next thing that we'll probably want to consider is whether there's a need to protect the health endpoint, given that there could be additional configurations that we need to ensure on the platforms. So for example, on the Kubernetes platform, they have this liveness probes and readiness probes. Or if you're using Azure Application Gateway, we'll talk about in a little bit, right? They have health probes. Some of them have the capability to put in additional authorization contacts, but this would also mean having to ensure that additional configuration. So and that might complicate efforts. So a best practice is we should protect our microservices on the Azure platform with either like Azure Front Door or Azure Application Gateway, which can have a web application firewall that ensures traffic has been scanned for malicious payloads, right, as an example, but also kind of acts as the front end, so our microservice is no longer kind of sitting all the way in front, which means taking advantage of that, we can actually set our endpoints to be anonymous from the perspective of doing the health check. And so that's one option of configuring our health check endpoints. So we'll also need to consider the use of application insights, which is a Azure Cloud native service to track the health and monitor the health of the microservices, right? So one nice feature about application insights is that it has a feature called application map that shows the entire environment of microservices with lines connecting to each other, right? So it's really a map that can tell us where there's an issue, because as microservices are talking to each other or talking to the backend database, if there's an issue, it's tracked, right? So there's a red line that you can actually see that says, hey, there's an issue here, and someone who has operational access can actually click on that line and be able to drill down and look at the specific issue or problems. Application Insight will also, with configuration with some languages, show the dependent calls throughout the stack and provides a view on what the exception is, right? So like the .NET stack trace could show us, which line of code is having an issue. And this is great for developers because developers will be able to tell quickly where the problem lies. So with containerization, this is kind of the last point that we're going to talk about from a solution perspective, is we can deploy the microservices to many platforms on Azure, such as Azure App Services, Azure Kubernetes Service or AKS, Azure Container Instances, or there's a preview version of a brand new container service called the Azure Container Apps, which is currently preview service at the time of this recording, but hopefully it will go GA soon. But this means we'll have the flexibility to choose the right platforms as we're thinking about going to production, right? On the Azure platform, I just want to maybe mention another service, which is the Azure Container Registry that provides a private hosting for our container images, right? So this is a cloud native service for that. The Docker Desktop is a free for personal use solution, but if we're going to use it for commercial reasons, it is a paid product. But it is a good way for developers to develop and run their containers locally, and very much integrated with IDEs such as Visual Studio, right? So, for example, when creating a .NET project, we actually have the option to auto-generate the right Docker file for our .NET based microservice. So without ado, this is kind of the final implementation on an architectural level for the IT team, right? And we are going to be proposing that, from a software architecture perspective, we're going to be proposing creating an issue microservice API, which is that very top blue box in the top, which contains all the front end pieces for people to call our API, and it will contain a health check endpoint for checking the status of whether our microservice is healthy, and noted that there's a line going to the DB, so it's going to perhaps do like a select one, right? Just to, hey, can I connect to the database? And that's it, right? They're very short and quick command. The other thing is we're going to expose a Swagger endpoint so that, from a development perspective, developers can just, directly look at, what are their APIs, that we've created. But perhaps this will be disabled in production, right? Because we may decide to use API management. There's a /issue endpoint, and we can certainly do the REST conventions on this issue resource. So a post would create an issue. And then once an issue has been created, then through the pub/sub mechanism, a service such as a scheduler service may pick it up. We can get a microservice issue. So, let's say a customer, goes back and tries to check the status of the microservice, can use a get, HTTP get verb. A delete, could be, I no longer need to have this issue, I'm going to delete it, or, maybe I've created a duplicate, I can always delete it. And a put operation, which basically, says, hey, service has been completed, right? And perhaps we have a survey microservice that shows up to track whether, the customer satisfaction, for example. All right, so up next, we'll do an overview on the final solution through a demo, which really is a .NET project, .NET microservice project with all the bells and whistles that we've talked about. All right, so here we are on the demo. And the first thing that I'm going to show is, I'm using Visual Studio for my .NET microservice project. But what I'm going to do first of all is kind of show the integration in Visual Studio from a development perspective with Docker, right? So whenever we create a new project, and let's say we're creating a web API project, we certainly can name our solution, but there is an enable Docker option, and we can choose the OS, but typically we'll choose Linux, and that will create the necessary Docker file. And so this shows kind of the tight integration between Visual Studio and Docker. And so let's go ahead and begin by looking at the program.cs, which is really the entry point into our application. And we can see that on line 10 and 11 is where we're making use of the Microsoft Authentication Library, or MCL. And we can see that we're using the JWT bearer defaults for the authentication scheme, right? Which means there's a bearer token that it will check to make sure it's there when we're calling the API itself. But there's also the configuration where Azure AD is in the configuration file storing some of the settings, right? So let's go ahead and take a look at in our app settings file, right, where that Azure AD is, and we can see that we have configured an instance, domain, tenant ID, client ID, and audience, right? And if you've seen some of my other previous videos, you kind of know that this is some of the settings that points back to the tenant, the Azure Active Directory tenant, where we have our app registration for our application. So let's go ahead and go to the Azure portal now, and so that we can see what are some of the configuration or where some of this configuration settings came from. And the first thing that I'm going to do is let's talk about this app registration, the Contoso Pest Control API that I've created here. So, the theory is it's not just for the issue microservice, but it's also for other microservices, right? And we can kind of reuse this app registration for all of that. What I did here is I created this particular application ID URI, which is specific to my app registration, and kind of allowed, expose this API, where I have another client that I've created that I can use in, right? So this is what represents my API, but I do have another app registration that represents like a client calling to, calling my API. I've also defined an app role here, right? Especially if this is going to use the client credentials flow, right, which is a service-to-service communication. We probably want to create an app role to kind of represent, this context, right? So here I've created an app role, which is just service apps. So let's go ahead and go to the Contoso Pest Control client. So as we've seen here, right, I've created this API client, and I actually created a client secret, right? So as we know with client credentials flow, there's a client ID and client secret that we will need to use to get a bearer token that allows us to access the Pest Control API. And then under API permission, we can see that, I have added the application typed permission for being able to access the Contoso Pest Control API here, right? So this is kind of the basic setup in order for the security aspect to work. The next thing is let's go back to the program.cs file. And, as we start looking on the bottom, we start to see the Swagger configuration, right? On line 14, start to learn more about configuring Swagger. And this is actually auto-generated. A lot of this code is auto-generated for me. But, the kind of configuration that I actually need to code is, this particular session where, we need to tell Swagger, hey, it's using a bearer token, and, this is what you want to show, right, to the developer in the Swagger UI page, that they need to enter a bearer token in order to call the API. So this is kind of, we need to call the add security definition and then add security requirement, right, which will allow us to do that. I'm going to go ahead and scroll down a little bit more. And here, we start to see kind of this particular service called the DAPR client PubSub service, right? And so let's go ahead and go into this particular service itself. And so this is actually a proxy or a wrapper around the DAPR client. And the DAPR client is what creates the abstraction for us away from implementation such as RabbitMQ or Service Bus, right? So in this case, I'm injecting the DAPR client into my service itself, and then on line 26, so if I need to publish any type of event, in this case, I've configured it to scope it to issue event type. This is the library that allows me to call the publish event async command. And underneath the hoods is where it will be able to configure to the right concrete implementation through some YAML configuration, which we'll see in a moment. But the full context is, I need to provide the name of the PubSub service. I need to provide a topic, And then, message is my custom message, right, of what I want to send to the topic queue itself. So with DAPR, the way that I've configured it is, I have this YAML file inside a folder called components, and we should be able to save it anywhere in any kind of folder, but in my context, I'm saving it inside this folder called components. And here you can see that I have configured it to talk to the Azure Service Bus, right? So on line 7, we can clearly see that the pubsub.azure.servicebus relates to the fact that I want to send all my messages to Service Bus. Now, if this is a RabbitMQ, right, the type would definitely be different. The next thing that will be interesting is I do have a connection string, but my connection string is I'm actually using a reference. So what this means is I'm not checking in my code, my secrets, along with this pubsub.yaml, right? So I do have to check in this YAML file, but I'm not going to check in the connection string. And so this is where I'm saying that, hey, there is a dependency on the secret store that is built into DAPR, and I've named it Contoso Secret Store. So if I go back to another file called local secrets.yaml, you can see that in this particular case, I have said, hey, I have a file that contains all my secrets, and it's in this file called secrets.json, right? So if we look, right, I'm not checking in this file called secrets.json, but you can see that this particular, and I'm not going to show us the connection string, obviously, but this is a true connection string that I'm not checking in this particular file, right? So from a checking perspective, if this is going to be instantiated by another developer, obviously, we can certainly share the connection string, but this file should never be checked in, right? Because it contains the connection string to Service Bus itself. So if we go back to the programs.cs and we look at the concrete implementation, right? Again, from a code perspective, even if we change to RabbitMQ, we just have to change the YAML file, but we never have to change a line of our code, right? Which is exactly what we need. So the other thing is, just to show that there is a real service bus. This is where the service bus is located. If we look at queues, this is where my service bus, where I have this issue topic, and this is where I'll be publishing all my messages too. Let's actually go back, because I think there's a key configuration that that kind of was important for me, at least, called disable entity management. So if the queue doesn't exist, then by default, this particular implementation will try to create it. But what that also means is the connection string that you're creating will need to have the manage permission. So if we go back to the service bus and we look at the queue itself, and we look at the permission policy, so we can see that the connection string really is where you define, hey, does this connection string has a manage or send or listen permission, right? So we will probably be giving it too much permission, because we do plan to create the topic through CI/CD process, and so really we just need to create a send permission and then use that generated connection string in our connection string file, right? So from a permission perspective, this is one of the things like a DevOps engineer would be interested to to be knowledgeable in. Okay, so let's go ahead and go back to our code. And we'll go down a little bit more where we are. So this is where entity framework is being used, right? We're using the addDB context. We have a addDB context defined, where we have the issue model created, right? And this is the definition. So it's in a table called issue, and then it's using the convention. So if I name it ID, this is the primary key, and so on and so forth, right? So this defines the issue model. But the interesting thing here is that we are also using things like enable, retry, and failure, right? Which is important in the concept of cloud because there could be transient errors that are happening in the back end, and so instead of having to build in retries yourself, right? You could certainly want to use some of the built-in code such as enable, retry, and failure to take care of some of those considerations, which means you don't have to do that, write custom logic or code. It's all taken care of by you. The next thing that we want to look at is health checks. And I think, all of us are kind of, we're interested to see some special code in addDB context, which we might not see often. But what I did is I have implemented the iHealthCheck interface in my addDB context, where I'm actually issuing very simple command, right, to check for the health of the connection to the database as part of my health check, right? So I'm doing a select one here, and then I'm returning healthy, right? But if there's an issue with that command, perhaps there's a connection issue, then I'm returning unhealthy. So by that, right, I'm able to just, when I do the @health check, which is again part of the framework for writing that /health endpoint is what I've defined. This allows me to use that as a way to do that additional checking, right? So if I have additional dependencies, I can certainly add more health checks down here, but this is the only dependency that I have right now. So just going down a little bit to line 101, 102, and 103 is where I'm creating that /health endpoint using the map health checks, and then I'm saying I don't need authentication authorization. Anyone can just call it to check for the health, and it will be a simple check, select one, which will just be a quick connection check. So the next thing that probably would be interesting is, and we can see here that the Swagger UI is only available in development because I do plan to use Azure Application Management, Azure API Management for my front end, for my API. And so I don't really need to have that Swagger UI, but for development purposes, it's good to have Swagger UI available so I can see, what's the API that I've exposed locally. So I'm going to go to the issue controller next. And, we talked about the pose, the get, the delete, and the put verbs. And this is where all the implementations for that is happening. This is all built in to, if you're developing in .NET, this is all available. And, some of this lines here helps with the response in crafting the response that is showing up in a Swagger UI and OpenID specification as well. So it's important to do some attributions here from that perspective. And then obviously I'm returning the appropriate response, right? Either okay or not found kind of thing, right? Just following the RESTful convention this way. So let me just look. So I'm just gonna do another thing real quick is I do have a unit test that I've written here. So right, any microservice projects should have both integration, unit integration, and functional tests available. In this case, I've started to write some of the unit tests using N substitute for some of the dependencies that I don't really need to worry about. And just gonna run a test real quick. I'm gonna go to Test Explorer. I'm gonna run, and just to make sure that everything is good before we continue. Right. So all the tests looks good. And one good practice is always ensure that your unit tests, however many you write, right, they shouldn't be taking a long time to write. In fact, you should technically try to run within 5 minutes or less, right? As a standard would be the best. All right, so I've talked about using Docker for development purposes, and so let me go ahead and show what I have in my Docker. I've actually did a DAPR init, which started to configure my environment with some of these dependencies. But I've also ran a command to install a SQL Server, a container image running locally, and this is actually free and open to be leveraged, in your local instance. But what I'm going to do is I'm going to try to start this instance, and let's see. My Docker could be stuck right now, so I'm just going to try to restart it. Okay, so now I've seen the icon. I'm going to hit start here, and that should be running. So I need my SQL Server running because my issue microservice is having a dependency on that. The other thing that I want to start is Management Studio. So I'm going to try to connect to my local instance. And we can see that I have a local instance. So I actually have a connections to this database called Contoso 2. But what I'm going to do is I am going to delete this guy because I want to show the DAPR, right? Which we talked about earlier. So what I'm going to do here is I'm going to deploy data tier application. And if you recall, right, DAPR contains all of the information related to the database model. And that's what I want to recreate in my environment. So give me a quick second while I pull up. Yep, so I do have my DAPR here, Contoso issue MS DAPR that I've created. I'm going to run it locally. I'm going to call it Contoso 2, which I had deleted earlier. And so now I am deploying my DAPR. So if we imagine, right, we could also do this as part of our CI/CD process, where we can create the schema of the database and do any upgrades by simply deploying the DAPR or the updated DAPR, right? So everything should be deployed. I'm going to hit finish. I'm going to refresh to check my database. And yep, I do have a table called issue here. My database is successfully deployed. So I am going to start the solution. But the way that I'm going to start it is I'm going to actually launch it with DAPR, right? Because recall that we are using DAPR for the abstraction to Azure Service Bus, right? So this is the command I'm going to run. I'm going to do a DAPR run. I'm going to give it an app ID. So if we recall, right, there's this element in DAPR for service discovery, and by naming my microservice Contoso issue MS or microservice, right, it speaks to to the name of my microservice. The next thing is components path, right? And if we kind of recall from the Visual Studio solution, I have my YAML file, created in a components folder, right? And this is the reason why I said, hey, if you want to name it differently, you could, but I'm just going to keep it as components. And then I'm going to do a .NET run. Okay. So the DAPR application was running. My application is starting up. And we'll give it a few moments. All right, so it should be started. So the first thing that we're going to do is I am going to launch a browser. So we can actually look at the Swagger endpoint. Okay, so again, we can kind of see that Swagger provides a UI, and recall that we actually had that authorized code, right? The bearer token code, and this is what that develops and creates, right? I'm not going to directly call my API here, but just to show that this is a Swagger endpoint and the OpenID Connect. I'm sorry, the Open API specification is also exposed, right? And this is what we'll provide to the API management service for creating any APIs later on, right? So this is important for that. But yeah, all our APIs are exposed, and Swagger gives us a good way to kind of see that being represented. So I'm gonna actually pull up Postman, and what I've done with Postman is I've created a list of actions that I'm going to take, right? So first action is going to get token through the client's credentials flow. Then I can add an issue, right? So imagining either the website or the mobile app, right? A user logging in and trying to create an issue, and this is the API for it, and I'm getting the issue back. I can update the issue. I can verify that the issue has been updated. I can resolve the issue, right? So once you resolve the issue, it's no longer allowing you to make any more changes. And then I could verify the issue is resolved. I could add another issue, delete it. If I do delete it, then I should get an 404 not found back, right? So created a list of Postman Postman payloads here. And so, first of all, I'm just going to get the bearer token. And what I've done is, I do have some Postman code to, now that I have got the bearer token, I'm going to put it inside the environment variable and start reusing it all over the place, right? So now I'm going to call the add issue API, right? And so it returns me with this particular ID 60D59, blah, blah, blah. And here you can see that now it's part of the environment variable 60D59, 08E, blah, blah, blah. And so it's just going to call it. We're going to get the same payload back that we've created, right? Yep. So this one, so when we added the issue, we were saying, hey, there's a wasp found in the kitchen area. This is happening for the last 2 days. Please help. Now I'm going to try to update the issue again because there's going to be more loss. So just acting as the customer, I'm going to do a put command. And so that should have been updated. I'm going to verify. Yep. So the update that I did was now 6 wasps are found in the kitchen area. Just come, please help. And perhaps a technician came, and now we can say the issue has been resolved, right? So it returns back 200 that says it's been resolved. Now we can verify by doing another get. And there's a resolution ID here as well. So let's say I'm adding another issue, getting an ID back, doing a delete. Okay. And that should have been deleted, and I should get a 404 not found if I try to use the same ID again. So this is all good, and this kind of shows some of the work that we can do in verifying or demonstrating some of the capabilities of our microservice, and using the example, the .NET microservice example here. So hopefully that helps, and we'll talk again soon. Thank you.